The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Yep.
With the log, ours right now is kind of like a Word document. Are you really wanting an Excel type spreadsheet?
Oh no, I mean,
Super concise.
a Word table is fine. I would like to see a table.
It looks more like a journal, I'd say, than a table. Like an entry for each time we test a day, stuff like that.
Yeah, I think that's okay. So it looks like as if you converted your table and then you did that convert table to text or something like that, and it looks like this paragraph format.
It's like the journal of our game, kind of. Yeah.
That's fine, as long as I can sort of trace the history of your game and the reasons why you make changes. That's the thing I'm really looking for.
Okay, you'll get
Yeah.
that.
The table format does make it slightly easier for me to read in the future. I like future things, but because I didn't make that clear this assignment, as long as I can trace the history of your game, I'm good. Other questions? And if anyone has a copy of the syllabus, do check the deadlines. I do think the one-page write-up is due the following week. On Monday, is due this coming Monday. I'm actually not going to be here on Monday. I'm be traveling to giving a talk, so Rick will be handling next week's classes, basically Monday and Wednesday. So I'll catch you. I'll grading might be delayed by a little bit.
Do you want us to bring like a physical copy or just like upload it to Stellar?
Upload to Stellar. Yeah, that one in particular uploaded to Stellar. For the assignment itself, for all the group submissions, I would actually like to see a hard copy so I can keep it all together. The game itself obviously needs to be hard copy, but then if I can get a printout of your changelog and everything, it's all in one place. Oh, by the way, on Wednesday I will come in with a whole bunch of Amazon boxes, old Amazon empty boxes, so that you can just like put your games into an appropriately sized box. And then, if you
have the sheets today to work on games a little more?
Yes. After this talk, I will go in, grab the prototyping cases, bring it down here, and you'll probably have at least an hour and a half, if not 2 hours, to work on it. Okay. All right. So today's reading was from The Design of Everyday Things, also known as The Psychology of Everyday Things. You'll probably notice we skipped from chapter 1 all the way to chapter 4. And part of the reason for that is chapter 4 is kind of a summary of chapter 2 and 3. Chapter 2 and 3 has like tons of nice case examples and sort of walks you through the reasoning, explains things in detail. Again, I would recommend this book to anybody who's doing any kind of design where a human being is expected to touch your design. It's really, really easy read. Hopefully you enjoy today's reading. So what I'm going to go into today is actually a little bit more detail about the stuff that wasn't covered in chapter 4. In chapter 3 in this book, Donald Norman actually lays out his mental model of how people make decisions when they are confronted with a piece of technology or a designed object that they don't quite understand. And he refers to this briefly in chapter 4, but I thought I'd like to go into a little bit more detail about this before going to the stuff that's actually in chapter 4. So he's got this basic idea that every time you interact with any kind of technology, whether that's like a chair that you've never seen before, or a car, or a computer program, you kind of go through this loop. You've got some goals as an individual human being. You get a new microwave oven and says, man, I will like to eat something. And then you go through this loop of trying to figure out how this new microwave oven works. You have some sort of intention. The goal might be, okay, I want to eat something, so my intention is to warm up this TV dinner or something like that. I plan. Okay, the plan is that I've got to prep this TV dinner somehow, so I'm going to go through this series of steps. I guess I need to take the wrapping off. Maybe I peel back the plastic a little bit. I mean, sometimes I get confused too. And then you actually have to like peel it, and then instead of peeling up nicely, it peels off into little strips. Does this ever happen to you? And it comes off in your fingers. That's the execution part, right? So it's like, I know what I wanted to do, but I actually have to go and do it. And then I get feedback. I guess I'm not really talking about microwave ovens. I'm talking about just the TV dinner right now. Okay, I see the feedback. The thing peeled back, but it didn't peel back in the way that I wanted to. I see it. I have to interpret whether that's getting me closer to my goal. It says, well, all I really want is a couple of holes for steam to come out. So, okay, I guess that's good enough. And I evaluate that as being good enough. So I can proceed to the next step of my plan of getting dinner. So my intention now is to actually put this thing into the microwave oven. I've planned to heat it up for 30 seconds, which means a series of steps to actually push in buttons to heat it up for 30 seconds. I have to make sure I don't set it to 30 minutes, so I actually punch the buttons and make sure I don't hit too many zeros. I see the feedback on the screen. I perceive whether that's what I wanted or not. Sometimes it's not what I wanted. Oh, I punched in 30 minutes by mistake. I interpret that the 30:00 as 30 minutes. I evaluate. That's not where I wanted to do. And then I make another series of intentions to solve that problem. So this is the model, and it's actually 7 steps, even though I've got 8 boxes. 1, 2, 3, 4, 5, 6, 7. This thing here happens in the system. Happens with the thing that you're trying to interact with. You can expand this into, if you were using a computer program, this will be expanded into a huge algorithm, right? Or this is the thing that the computer has to solve in sort of figuring out what you were trying to do and trying to do and try to communicate back to you whether that was successful or not. That's not really what I want you to worry about right now at this moment. But these 7 steps are all happening in the human. And all of those steps are an opportunity for something to go wrong. Let me give you an example from games in particular. Okay, so these are some of the considerations that you might have in a game. Or let's say it's a competitive game. You want to win, you don't want to lose. So you figure out, how do I want? How can I win or lose? Gathering a lot of money or resources, or getting more points, or something like that. Knocking out my opponent. What are my options right now? Maybe it's a card-based game and the options are all laid out in the cards that you're holding. Maybe you have the same 3 decisions every turn. So, given all those options, what do I want to do? And then you actually have to execute that, right? If it's some sort of dexterity game where you have to flick tokens on a board or something like that, okay, that's kind of tough. Maybe it's you just place the card face down, but you have to make sure you pick the right card before placing face down and not placing it face up by accident. The game, reacts. That could involve other people. That could involve a computer. That could just involve how the board looks. And then you as a human being now have to perceive the state of the game and figure out whether that got you any closer to where you want it to be. You say, oh, I made that move, and man, that was a terrible move. And I know that because that took points away from me. So now I need to figure out what's my next step. I make a plan and go on and so forth. So the idea that Donald Norman talks about mental models is basically this idea that the human beings who are playing your game have an idea of how your game works. And it might be right, it might be wrong, or maybe somewhat vaguely right, but not quite there. Now, if you're a designer of a game, then you are creating that system that the player is interacting with. Everything that I talked about earlier was happening between the player and the system. And you're this designer who's trying to machine the system into something that the player can understand. Now that should actually kind of sound familiar because we talked a little bit about this, mechanics, dynamics, aesthetics. You as a designer in designing a system are creating the mechanics of a game. Players experiencing the aesthetics of the game, there are all kinds of resultant dynamics that are coming out from both how your rules define what the player is going to do, as well as how the player decides they're going to execute your rules. So it's this weird, horrible second-order problem, which results in you trying to communicate to the player, this is what's happening underneath the hood, and you really need to understand this to be able to make good decisions. So again, the player develops a mental model about how the system works by interacting with the system. The player tries to play a game by poking at it, and the user then uses that mental model that happens to exist in the player's head to anticipate what that system is going to do in the future if they did something differently, and that mental model gives the player an explanation about why the system is behaving in the way that it does. The designer also has a mental model. You all have an idea of how your games currently work. Whether or not your games actually work that way, because if I read your rules, I may interpret it differently. But right now, you have an idea of how your game works because you've been working with these things for like 2 weeks now, right? And you're materializing that into a set of game mechanics, a bunch of rules, that the player then has to interpret, and then create their own mental model out of that. So you can imagine so many different possibilities of things just going wrong. I'm going to talk a little bit about that. So one of them are mistakes that a player makes. There are two different kinds of mistakes that I want to talk about. I'm trying to introduce this vocabulary to you so that when you're talking with your teams, you can use clear language. If you've gone through CMS 611 before, you've seen a version of this presentation. I tried to change up the examples so that these are board game examples. Slips are the player knows what's supposed to happen and what they're supposed to do. The player just happens to accidentally do the wrong thing. Real world slips including anybody try to call somebody on the phone, dialed in a number, and accidentally dialed somebody else that you know really well? Okay, it's not like you didn't know each person's phone numbers. You just automatically started dialing the wrong number, which you also knew very well. If you drive, you want to drive to your friend's house, you accidentally end up at work, because you kind of just got into the routine. Halfway through a task, you forget what you're doing. It's not like you don't actually know what your task is. You just happen to forget it in the middle of doing it. Pushing a similar button to the one that you actually wanted. That sort of thing. Dealing cards. Everybody gets 5 cards. How many have I dealt? It's like that person has 5 cards, 6 cards, 5 cards, 5 cards, or something like that. And people come up with systems like this to be able to help them keep track of how many cards that they've dealt. But it's not like you didn't know that you were supposed to deal 5 cards to everybody. You just kind of lost track halfway. So that's a slip. That's not a problem of a player's mental model. The player actually understands how this game is supposed to work. Yeah.
Oh, sorry, I was just
Oh, okay, no worries. But then there are also mistakes, which are errors in the player's mental model. The player thinks the game works in a certain way, and the game isn't actually supposed to work in that way. So this is a product placement shot, a beauty shot of a beautifully handcrafted, machined Settlers of Catan board. How many of you play Settlers of Catan now? Okay, what's wrong with that?
You can't play cities.
Yeah. Yeah, you can't put cities on adjacent slot. Actually, I think you can't even put it adjacent to your opponent's cities, right?
2 apart.
Yeah, 2 cities cannot be right next to each other. It makes for a nice photo, but the person who set this up clearly doesn't actually play the game. But it's still a beautiful board. You see, that player has. If this person was actually playing the game, this person has the wrong idea about how this game is played. That's actually sometimes perfectly fine. That's part of learning. You make a mistake. If the game corrects you, and then you learn how to compensate for that or play differently, then that's just the process of learning the game. People make mistakes while they're learning the game all the time. If you're playing a computer game, sometimes that's all of the fun of playing the game. Just trying to figure out how this crazy computer game works by prodding it, and then the game punishes you because that was the wrong decision, and then you learn not to do that, and then you try a different strategy. In fact, a game where you never fail, and it's actually fairly easy to make a computer game where you just never fail, isn't that interesting for a player, because that means you can just use whatever strategy you went in with, and it will always work. There's no reason for you to think that this game needs more strategy or has any depth to it. Whereas a game where you try out the strategy that you came in with, and maybe it works a little bit and then it stops working, and then and you're getting feedback on why it might not be working. That tells you, hey, maybe there's a little bit there's something underneath the hood here. Maybe I can explore this game a little bit further. There was an interesting study from Jesper Juhl, who is a game scholar, who wrote the book The Art of Failure. And one of the tricks that he did, he made this really simple kind of snake type game where you pick things up and then the snake gets longer. And he compared, and then he asked people to just rate the game at the end of the game. The game's the same, no matter who played it, but some people played it better and some people played it worse. The people who never failed once in beating, I think, like 5 levels of the game, rated that game as being lower as someone who failed once or twice. And somebody who played once or twice were rated like a 7 or 8. Some people who never failed, they rated like 5. And people who could never get past the first level were also rated like a 5 or a 4. So people who get frustrated if they can't find the right mental model to play this game. It's like, none of my strategies work. I don't understand this game, I don't get this game, this is frustrating, I hate this game. And the alternative is, I completely get this game. I saw right through it the moment you put this in front of me. I beat it, in less than 5 minutes. My strategy just worked. Not much there. And then the people who kind of failed a little bit halfway, but then managed to complete the rest of the game because they changed their strategy, thought, hey, it's a pretty cool game. It gave me a challenge and I overcame it. So let's talk a little bit about feedback. How do we give users this kind of really, really valuable information to correct those mental models? I guess I'm skipping to the right side of the slide here. So we need to tell a player that an error has happened, and we need to give them tools to recover. Often in a board game or in a card game, that kind of telling the player that an error has happened, it needs to be enforced by other people. So you need to give other players tools to detect when the game is on the verge of crashing, right? When someone's executed an illegal move, and then give them some sort of structure to be able to correct that. I'll give you a little bit more examples about that in a second. The alternative, of course, is you just let them make the mistake. There's on occasion, they're making a move that is an error, that is a mistake, because they didn't understand how this game is supposed to work, but it's a legal move. And then you want, as a designer, you have the option of giving them tools to fix that problem. It's like, all right, you made a suboptimal move. It wasn't going to get you anywhere closer to your winning goal. But I'm going to give you various kinds of mechanics, various kinds of rules to be able to then recover from that mistake. Of course, you can also just prevent some of those mistakes from happening, right? In the Settlers of Catan board, they actually had slots of the right size to be able to put various pieces. And that's a constraint. That's a physical constraint that prevents you from putting the wrong piece in the wrong place. Ways to be checks and confirmation, again, usually tend to happen with other players or maybe a referee. Especially in sports, you want to be to think about the role of the referee and what the referee should be checking for. But if you're making a computer game, then of course the computer is doing that for you. Let's talk about several kinds of error recovery. There's backward error recovery, which is undo, basically. I'm taking back that move. In chess, the rule is if you've got your hand still on the piece, you can still take it back. Isn't it?
Not in tournament play.
Not in tournament play?
In tournament play, it's touch move.
It's touch move?
So you have to move that piece, but you can move it to a different spot as long as your hand's on it.
Right. If you touch an opponent's piece, you have to capture that piece.
Yeah.
If you touch your piece, that means you have to make a legal move with that.
Yes, you have to make a legal move with that.
Right.
But you could, if it's a knight, I could move this way or I could move that way. If I moved it that way, I can still move it over there if I haven't let go yet.
Right. I think yes. So you hit the clock.
Yeah, until you hit the clock. Because in tournament play, especially when clocked in time tournament play, which is how it's usually done, there's still a penalty for that. You're still losing time even if you're correct. But at least there is a very clear stated set in the rules of this is how you take your move back. And this is when you're not allowed to take your move back, which is basically when you let go of the piece. Forward error recovery is more about, again, giving people tools to be able to compensate. Mario, this is not a board game example, obviously. You jump, and you can change your direction in midair, right? So you can do a jump, that you're not going to complete and you will fall to your death. But you can go backwards while you're flying in midair, and then land back where you started. And again, you lose time, but otherwise you haven't lost the game yet. So that's forward error recovery, right? You've made the decision, whoops, that's not the decision I wanted, and then you fix it. So you take a new action to compensate. Now, affordances comes up in Donald Norman, but I believe he goes into more detail about it in chapter 2 and chapter 1. So I'm just going to go into different kinds of affordances and constraints. So affordances are things, are aspects of the thing that you're confronted with that invites you to do something. So we talked a little bit about the affordances of materials, right? Glass invites breaking, porous wood invites writing on. Door handles are one thing that comes up a lot in Donald Norman. We have a door handle that's not all that different from this on the door in this class, and that handle, it's about hand size. It invites you to sort of grab it. You could turn it, you could pull it, you could push it. So there are various constraints when you look at a door like that door that tell you about what that function of this handle is supposed to be. First of all, there's like a semantic constraint, right? You've been taught that thing is a door. You've seen a million doors just like that, and so you say it's a door. It must open somehow. Any of you just found a random door on campus that just doesn't open? Like it's not like it's locked. It actually just doesn't open. Or maybe it opens into a brick wall. Yeah. And another example?
No. Not here.
Right. Yeah. Does it not open, or does it open into something that bizarre?
Into a wall.
It's a brick wall, right? Yeah. So that's betraying the semantic constraint, right? The door is not supposed to open into a wall. It's supposed to open into another space that you can go through. It's a door. It must open somehow. And so you look at a door and see all of different ways that you can open it. Now, in emergency doors, you get these things, often called crash bars. And what you see over there is pretty popular, but not the only way to implement this idea. A crash bar is designed so that you make it very, very clear that this door only opens in one way. Try to limit how much mental processing you need to think about, because it's usually put on an emergency exit. But this particular one, you could grab this. You could grab this with your hand. You could push it, you could grab it, you can pull it up, you can push it down. There is a logical constraint that as the moment you grab your hands on something like this, assume that you can't see the lock. You're just seeing the door and the door is closed. As soon as you grab this thing, you realize that this hinge is spring-loaded and can only go down. So there's this logic. There's a logical constraint there that this is a hinge that can go up and down, but it's already in the up position. So in order to activate this thing, you push it down, which encourages pushing rather than pulling, right? So it encourages you to exert force in the correct direction, assuming that the door opens outwards. If it opens inwards, then you've really put the door handle on the wrong side of the door. There are also physical constraints. Back to the example that I talked about, the Settlers of Catan board. This is a different kind of crash bar. But this one I think does a slightly better job, because this one's actually kind of difficult to grab. It's actually pretty wide, and it's much and it's wider than a lot of people's hands. It's really easy to push. So just physically makes it difficult for you to do the wrong thing, to pull on a door that actually opens outwards. But of course, this thing doesn't tell you where the hinge is. It doesn't tell you whether the door opens to the left or the door opens to the right. And if you push too hard on the wrong side of the door where the hinges are, the door doesn't really open. I guess if you push really hard, it will still open. But if you just gently push it, it doesn't open, which is why you get these, which are offset to one side. And there are cultural constraints that are associated with that. Like the blue, slightly rubberized, grippy surface that encourages you to put your hands on that. There's a physical constraint, of course, because it's off-center. If you push anywhere along this bar, you sort of generate enough torque to be able to open the door easily. I'm not so sure about this sticker that's over here, but I do think that kind of informs you that this is not actually something where you have to put your hand on, because stickers rub off and there's ink on them and they don't last very well. Whereas this is rubberized and it's coated and it's clearly hand-sized and it's inviting you to push it. So there's this cultural surface of the colors, of the material, of the rubber that says this is something for you to put your hands on. So those are 4 different kinds of constraints that I went through. The cultural constraints, which is what I was talking about, the blue. There's the physical constraints of just making it hard for you to do the wrong thing, in the same way that certain pieces in certain games are easy to pick up because you're going to be picking them up a lot. Certain things are easy to roll. And certain things are hard to pick up because you're not supposed to be picking them up. Maybe you're supposed to be sliding them around. There are logical constraints where if you just look at it for a second, you will say, well, it can't be this, therefore it must be that. And finally, there are semantic constraints of when I say something is a door, you expect to be able to go through it. Same thing for a game. If you see a door in a game as labeled door, you expect that door leads somewhere in the game. I think there was a version of Clue that I used to play when I was a very, very little kid. And if you remember the Clue board, it kind of looks like a floor plan of a house. And it has windows and stuff like that, and that implies that you can go outside of the house, but you can't really go outside of the house. That would be breaking the rules, and that confused me when I was 5 years old, because I expected that you'd be able to go through any door. A couple of other things that you can do to help people understand your game is context, where how things are placed next to other things that suggest how they're supposed to be used. So this is, Boggle, and when you open it, you get these 2 pieces. Well, you actually get 16, 17, 18 pieces, 19 pieces because there's a cover. But you get these 2 things together, and as soon as you see this, if you know what an hourglass is, you immediately know that this is a timed game. Whether or not you read it on the box that this was a game that was timed, or whether you've ever played this game before, when you see a timer that's packed in the same box with things, that it suggests that this is a game that's going to be played with a time limit. So that's one way of thinking context. I'm going to go into a few more examples later on, and I want you to think about how how things are placed next to each other suggests how they're supposed to be used. Context also comes from just the way how you name things and how you provide art. This is not something that you have to worry about in assignment 1, but you're going to have to start worrying about it in assignment 2. How many of you have played diplomacy? Okay. You still play diplomacy with the same people that you played with?
No.
You don't talk to them anymore? No, okay. That's the problem with diplomacy. How many of you play Risk? Okay. If you just look at a diplomacy board or a Risk board, they don't look all that different. It's a world map. Or I think in diplomacy it's like a Northern European map. But this game is a game of international intrigue, trust, and treachery, and it's called diplomacy. And this game is called the game of global domination, Risk. And just look at the way how they're presented, right? Actually, why don't you tell me, what do these boxes tell you about these games?
Risk has a bunch of cannons and soldiers, so you're probably going to be fighting and attacking stuff.
Okay, yeah. It's about conflict.
Diplomacy, I don't know, it looks like guys kind of sitting around, and there's a sword and some wine glasses, so maybe there's a bit of fighting or a bit of wheeling and dealing, but it just seems like mostly you'll be talking to people.
Okay, there'll be a lot of talking in this game. Yep.
I sort of get the sense that they might be like leaders or something discussing a deal.
Mm-hmm. There's a world map and a globe, just to remind you.
Like an inkwell on my table.
Mm-hmm. Mm-hmm. Yeah. You're making decisions on behalf of the world. Yeah.
If anything, it seems like these are the people who are behind the throne and not actually maybe making kind of shady deals.
Like shadow presidents or something like that, or kings. I guess at the time of that this game is still like the world of Tsars and Kaisers and so. And then, okay, all right, so you're making shady deals in diplomacy to be able to determine the fate of the world. And in Risk,
Attack!
you just stomp over everything, right? It is like, you know, I'm going to take my army and we're going to meet your army and then we're going to like figure out who's got a bigger army. That's pretty much the game. There's also another hint, right, in the titles, diplomacy and Risk. You know, diplomacy is a game about diplomacy. It's about talking to people and making deals and breaking deals at opportune times. And this is why people who play diplomacy don't often play with diplomacy with the same people anymore. It's a great friendship killer. Risk is a game about I'm going all in. You know, it's like, you know, I might win this if the dice, you know, roll in my favor. So it's about risk. The game's about risking everything on big gambles, and it's actually a pretty good example of what this game's expecting you to do. So immediately, just by looking at the box, the game's already trying to condition you to thinking the way that you need to think in order to do well in this game. Let's see. Visibility. This comes up like a million times in Donald Norman. And when you're designing your games, you have to think about how to be able to make what's happening in your game more visible to the players who need to make decisions about them. This is a very close-up view of a game called Cosmic Encounter, which we will play later on. And it has kind of this risk-like element that I am going to put my army of flying saucers against your army of flying saucers. But we're going to be fighting on multiple fronts at once. And that's actually going to be, in that game, you can join forces. So I can team up with you to go up against a planet that's being held by you, but then somebody else is going to join in and try to help defend your planet. And so they have this system of stackable tokens to be able to very, very easily see whose pile is higher. Right now, these are all the defenders, so they're all on these little planet-shaped disks. There's actually this big flat spike where you stack all of the attacking ships and you point them in the direction of the planet that you're attacking. So it just makes things very, very clear. This is how big the army that's attacking is. This is how big the army that's defending is, even though there are many, many, many different forces being involved. So they're making visible what the current state is. And again, it's kind of like a diplomatic game like diplomacy. In the middle of every combat, you have both sides just asking all the players who are not involved in the combat to please contribute something to this. Please contribute a ship or two to this attack, and they're making deals all the time. Even games that are not really about visibility take advantage of visibility, right? The whole idea of Battleship is that you don't know where your opponents are. But they give you all these useful tools, these red pegs and white pegs, and a whole extra grid to be able to keep track of where you've bombed before and where which ones were successful. Yeah.
I'm imagining Battleship without the second grid.
Yeah, it's possible. Yeah, I mean, you'll probably end up drawing your own second grid pretty quickly just to be able to keep track of where you hit before. There's other things up here as well, like it has the shape of all these, and I think underneath it actually has words describing how big each ship is. You've got your own fleet to keep track of what all the possible ships are and how long they are. This person actually uses white tokens to keep track of where the enemy has bombed, which is something you don't have to do in the game in order to do well. It's not usually useful information, but you have the tools. The player has all of these tools to be able to keep track of that information. So this game has gone a long way to try to make the little bit of information that you do get over the play of the game, the little bit of hidden information that you reveal over the game, as visible as possible, so that you can make the next logical decision as easy as possible. Previous user experience goes a long way in helping people understand games. And all these are dice with non-traditional numbers that you expect to find on a dice, but you see a dice, you kind of know what to do with it. You pick it up, you roll it, and it will give you a number, and that number is the number that you have for that turn. There's also like the little dot that sort of distinguishes the 9s from the 6s, and that comes from other games. I think a lot of people see that from games in particular, because I can't think of many other situations in real life where something might be flipped upside down, and then you have to interpret that number. In fact, there's a Kickstarter out, or at least there was a Kickstarter out for this project, which was just a whole bunch of cards with a whole bunch of different randomized things depicted in a sort of a photoshopped photo. So it was a whole deck of cards. I think it was actually a standard poker deck. But it also had all of these other randomizing things. So it had a Drano, it had a dice with suits on it, it had different sides of dices. It had one of those counting sticks. I mean, there's a couple of things here that I'm not even sure if I can tell you the name of it, but you can probably figure out how it works, right? Like what does that look like up here? Compass. Looks like a compass. Now, knowing that this is a randomizing element, how do you think that will be used if you actually had it in real life?
Spinner.
It's a spinner, right? Yeah. It's a hex-grid spinner in particular. Because you can spin it from 1 out of 6 sides on the inside and 1 out of 8 sides, I think. One out of 8 directions in the top. I have no idea why there's this inside here, but there are a couple of these things like the coin, right? The coins, you can use this deck of cards to do coin flips if you want to. And there's also this like weird fortune cookie thing. So anyway, it's a cute little idea, but I don't need to explain to you how to use this. It's just a whole deck of different pictures on it, and you can use it to randomize different letters and different numbers. Huh?
So what was the Kickstarter?
I forget the name of it.
No, I mean, what was the point?
The point was that you will get a deck of cards and every card is different, and every card looks kind of like this, but it has different randomizing results on it. Cultural cues. This was actually played. This is actually a pair of friends. There is a game called War on Terror. It's a very satirical game. Basically, everybody has exactly the same strategy. Everyone's in charge of a country. Basically, everyone's after oil. Everybody has the same strategies and the same tactics. But yeah, if you cross a certain point, you get branded as evil, and you have to wear the evil balaclava. And that immediately is a trigger for everybody to gang up on that person. Whereas what the game's really the whole point of the game is that the game is trying to drive home the point that everybody is all the powers are engaging exactly the same tactics. And at the moment that you actually get declared as evil, you actually get a little bit more freedom on what you're allowed to do, because you don't have to worry about other people branding you as evil. So the whole idea of here's this person in this balaclava, and it has the word evil on top to make it clear. But I don't think that was actually necessary. You just do this with a regular balaclava. It gets across the point that this person is now marked as the bad guy. Interaction metaphors is something that I actually had some trouble coming up with board game examples. It happens a lot more often in computers, where you get some sort of metaphor to imply how it's supposed to be used, but you're not going to exactly use it in that way. So, for instance, what are these things up here? Mail slots? So what do you think you do with them in the game, in this piece of software?
You can read the inbox or put things in the outbox.
Yeah, you can sort of send messages, and check what messages you received. That's a metaphor that we still kind of keep in mail software today. Anybody recognize that?
Rolodex.
Oh, people actually still recognize Rolodexes. That's cool. What does Rolodex do?
Contacts.
Contacts. So that just gives you a list of all the people that you've met. This gives you an idea of how old this screenshot is, right? Well, this looks like a planner, some sort of scheduler. lady? Magic lamp? Genies. You click on it and genie comes out. Asking things? Help? Maybe? Not quite sure.
Wishes.
Wishes. Maybe it connects you to tech support. I don't know. You can start to see the metaphor breakdown here. You know, this is a phone.
Pretty sure that's fax, maybe.
A fax, maybe? I'm looking at this and it's like, I didn't know a little bit about the machine that this was designed for, and it didn't have he couldn't make phone calls with it. So I have no idea what this thing actually does. Maybe it sent pictures. No, this thing looks like a purse or a briefcase or a bag. You know, it's a metaphor for something, but it might be cash transactions, but I doubt it could be your files that you saved. Who knows? Things are starting to sort of break down. But you still have this desktop metaphor that we still maintain in a lot of user interfaces. This is the real kicker. There's this extra button that takes you into the hallway, and I have no idea what to expect in the hallway of this user interface. Maybe it's other applications or something. We have that a little bit in board games, especially board games that are produced for many different languages, because they have they can't slap words on the tokens, because if you slap words on it and you want to then release the same product in a different language for a different country, then you have to change all the words, and that increases the manufacturing cost. So they try to use generic tokens a lot and then just explain everything in the rules, which they can print fairly cheaply, and they can include 6 European languages in the same bound like that with no problem. This is a game called Agricola. And it's called a worker placement game, because what it basically is that you've got a bunch of members of your family, of your little farming homestead, and then you send them out every turn to do various tasks, like you go to the fireplace and cook some meat, or go to the market and buy some more seeds, or build some fences, or something like that. So what you do is that you take these tokens and you put them on the card. So this is both context and an interaction metaphor. By taking this thing and putting it on this card, I'm achieving quite a large number of different things. I'm saying this is the action that I'm taking. I am saying I have 1, 2, 3, 4, 5 different things that I could do on this. Actually, I'm not so sure about this. This might be a baby. But there's like at least 4 different things that I can do on my turn. Every time I take one of these things and I put it on a card, like the card that you see on the right, that means that that's going to be my action for this turn. The other thing that this game does is that once I've decided that I'm going to do that, I think in Agricola, once you've placed it, nobody else can place it. So like I can sort of take over the fireplace, and no one else can take over the fireplace. I can't put 2 people on the same fireplace, certainly. So that's a metaphor, right? Now, it doesn't really matter that you don't. This game didn't really have to count everything in family members. It could just say you have four actions that you can take per turn. You just choose which 4 actions that you get to do all of the math that's necessary to improve your farm, and that's it. But they turned your family members into your action counter, into your action points. The more family members that you have, the more different actions that you can take within a turn. So your family members are your metaphor for action points. You get the same thing in other games with things like workers. Finally, just a very quick word about accessibility. This is usually something I go into much more detail in my computer games classes, but with board games classes, one thing I do want you to keep in mind is color blindness. I want you to, if you have color blindness, or if you have friends who are colorblind, you definitely want them to take a look at your design and see whether it's possible for them to play your game. Take a picture through Instagram or something like that and put in a black and white filter. See whether your game is still legible and possible to play with all the colors removed. You can accomplish a lot of things by just changing up your tokens. by putting additional marks on the tokens that are high contrast, so that they don't, you're not completely reliant on color information. You can look at bright and dark as well. If you take that into consideration in your design, you will definitely get kudos from the instructors when we are grading, because that means you've taken the effort in trying to increase the range of people who can play your game. So that's pretty much what I have to say about usability for today. Any questions so far? No. This is not something you have to worry too much about for assignment 1, but it's something that you definitely have to think about whenever you're trying to create a game for lots and lots and lots of other people to play. So for assignment 2, definitely start taking this into consideration. What pieces are you choosing? What do the pieces tell you about how to play this game? How does your board tell you how to play your game, even if your rules are not printed on the board? What are the clues that you're giving the player to be able to form that mental model, so you can get them past that learning stage where they're just making mistakes and start making decisions about how they want to play the game in a way that's satisfying to them, and giving them feedback on whether those decisions worked out or not. All right. So that's the presentation, and now I guess it's team time to work on your projects. I am going, Rick and I will go and get boxes, and we'll be right back. Okay, if anyone needs to take a break, now's a great time.